Good afternoon, everybody. We are going to be going over notes 3.4 today, which is writing linear equations. The learning target for today is I can write a linear equation in slope-intercept form, point-slope form, and standard form from tables, graphs, and verbal descriptions. I can use representations to make sense of and solve problem situations. That sounds weird, but okay. Anyways, before we get into the vocab for today, I did want to kind of remind you of what we've already done with our linear equations. When we first started talking about linear equations, I just kind of introduced you to them and their different key attributes, like slope-intercept form has the slope and the y-intercept, point-slope form has a point and a slope, and then you've got standard form, which honestly is not super useful. It doesn't really give us much. We can graph from standard form, but that's really all we can do with it. And then the day after that, we talked about how to graph from all three forms. So we graph from point-slope form, we graph from slope-intercept form, and we graph from standard form. So today, I want to talk about how we can write equations in these different forms depending on the information that we are given, okay? So our vocab today, we're going to start with our initial value, and the initial value is the starting value of a function, and that is always going to be when our input or our x value is 0. So if I give you an equation, for example, if I give you y equals 2x plus 3, and I say, what is the initial value? We can actually look at the equation and know what the initial value is, but if you're not sure, you can always input 0 in for x. That'll give you y equals 2 times 0 plus 3. 2 times 0 is 0, and you are left with 3. So your y-intercept or your initial value is always going to be whatever is at the end of your equation if you are looking at an equation. If you aren't looking at an equation and you're looking at a word problem, it's going to be the one-time fee or a like whatever your problem is starting with, okay? Your rate of change, we talked about this before. Your rate of change is just your slope, or literally your rate of change. And then we have two different variables. We have an independent variable and a dependent variable. Now, independent and dependent variables are going to be based on your x and your y's, because those are the two variables that we are comparing when we talk about functions or when we talk about linear equations. So your independent variable is going to be the variable that does not depend on another variable for its value. For us, that's always going to be the x value. And then your dependent variable is a variable that does depend on another variable for its value. That's going to be your y value. And we can actually look at this example that I gave you up above when I said the initial value. We said y equals 2x plus 3. Y depended on what I put in for x. So y is dependent because y depends on whatever I plug in for x, and I get to choose what I plug in for x. So that's why x is independent, it makes its own decisions, and then y is dependent because I cannot get my y value unless I know and I input my x value. All right, let's talk about writing an equation from a word problem. We've done this before in middle school. A cell phone company charges $80 per month for unlimited talk and text with your choice of cell phone. You buy the latest iPhone for $1,200 to use with the plan. What is the initial value or one-time fee? Well, hopefully you only pay $1,200 one time for your phone, so that is going to be our initial value or our one-time fee. The rate of change is what are we doing consistently? We are consistently paying $80 per month. We're not paying $1,200 every month because that'd be a lot of money, but you are going to be paying $80 per month, and because it's changing or it's a constant rate each month, that's going to be our rate of change. Now, as a reminder, rate of change or slope does not contain a variable, so I'm not going to put x with it. It's just going to be 80. Part C says write the equation of this problem in slope-intercept form. So your rate of change, although it is 80, when I plug it into my equation, it's going to be 80x. So my equation will be y equals 80x plus 1200. What is the independent variable and what does it represent in this problem? Your independent variable is always going to be x. Now, what does the x represent in this problem? It represents the number of months. And then what is the dependent variable? Y, because y, or my total cost, depends on the number of months that I am looking at whenever I look at my bill for whatever. And then part F says, if you plan on using this phone for 6 months, list the domain and range for this problem. Okay, remember that domain are your X values and range are your Y values. We have to think of this as a discrete function. So my domain is the number of months, because remember that your domain is your X values. So I can use the phone for 1 month, 2 months, 3 months, 4 months, 5 months, and 6 months. That's the domain. And then the range, remember, is your total cost. And that depends on whatever you plug into your equation. So remember that we came up with the equation y equals 80x plus 1200. I have to input my domain values in here for x to figure out what my range values will be. So let me pull up my calculator. Hello. There we go. Clear out whatever's in there. Okay, so I'm going to do 80 times 1 first because that's the first month, and then I'm going to add 1200 to that. And that means that my first range value will be $1,280. So that's what I'll be paying after the first month. After 2 months, my total cost will end up being $1,360. After 3 months, my bill would be $1,440. After, what did I just do, 3? 80 times 4 plus 1200 would be 1520. 80 times 5 plus 1200 would be 1600. And then 80 times 6 plus 1200 will give me 1680. So that is going to be the domain and range for this first problem. Number 2, you and your friends are planning on going to a concert. When you go to buy the tickets, you notice there is a fee to purchase the tickets online. Each ticket you buy will cost you $230, and then the online payment fee is $25. So the first part of my problem is, what is your initial value or your one-time fee? We have to pay $25 once when I purchase my tickets online. It's not per ticket. It's just no matter how many tickets I purchase, I have to pay $25. Okay. And then you are going to have a rate of change of 230. Write the equation of this problem in slope-intercept form. So we know, oh my gosh, I forgot. I can't do that when my calculator's open. Go away. So we know that we have y equals 230x, because it's $230 per ticket, plus my one-time fee of $25. What is the independent variable? Independent is always your x. Now, it's going to represent this time the number of people, or the number of tickets you buy. Either one is okay. And then E, what is the dependent variable? Well, y is going to depend on the number of people or the number of tickets you purchase. And y is going to be your total cost. Y is very often total cost. Okay, and then if 7 people, including you, are planning to go to the concert, list the domain and range for this problem. So my domain are my X values. There's 7 people going. People can only be discrete. You cannot have a continuous person, because that would mean that you have parts of people, and that's weird. All right, so if 1 person goes, I need to figure out what my total cost would be. Okay, so if 1 person goes, that's going to be $230 times 1 plus my fee of $25, and that would be $255. I probably should not have done that. Toot. Man, okay, there we go. Scooch. Okay, and then 2 times 230 plus 25 is 485. And then 230 times 3 plus 25 is 715. 230 times 4 plus 25 is 945. Man, these are going to be expensive. 230 times 5 plus 25 is 1,175. Bless me. 230 times 6 plus 25 is 1,405. And then lastly, 230 times 7 plus 25, you are going to be paying $1,635 for all 7 people to go. That's a lot of money. 1, 2, 3, 4, 5, 6, 7. Very good. Okay. Excellent. Let's look at 3, 4, and 5. These are very similar. It says a farmer is selling 2 different crops at a farmer's market. The options are bags of apples or bags of peaches. Each bag of apples will cost you $4 and each bag of peaches will cost you $6. The farmer made $84 last week in selling apples and peaches. Write an equation in standard form that represents the situation. So remember that standard form is AX plus BY equals C. So C is supposed to be our total, which we know is $84. Now, AX and BY are going to be representing the 2 different options that you have when you go to this farmer's market, or just your 2 options that you're comparing in general. So we are comparing bags of apples and bags of peaches. We know that each bag of apples will cost $4. So we're going to say that apples will be X and then peaches will be Y. So that's going to be 6Y. So the equation 4x plus 6y equals 84 will represent this situation or this scenario in standard form. Number 4, in football, each touchdown earns your team 6 points and field goals earn you 3 points. A team earned 42 points by only scoring touchdowns and field goals. Write an equation in standard form that represents the situation. So again, I have AX plus BY equals C. C is my total. My team earned 42 points. We scored points by only scoring touchdowns and field goals. So we are going to say that each touchdown is 6 points, so 6x, and each field goal is 3 points, so 3y. And there is my equation for the situation in standard form. Number 5 says, Sarah bought 5 shirts and 4 pairs of pants for $195. Kim bought 7 of the same shirts and 5 of the same pants for $220. This one wants us to write 2 equations in standard form that represent the situation. So I'm going to have Sarah's equation, AX plus BY equals C. So this is for Sarah. My C for Sarah was $195, and she bought 5 shirts and 4 pairs of pants. So that's Sarah's equation. And then Kimberly will be pink. Sorry, her name is Kim, not Kimberly. She is also going to have an equation that represents her purchases. Her total was $220, and she bought 7 of the same shirts and 5 of the same pants. So here we have 2 standard form equations for each of these 2 people when we compare the same shirts and the same pants. So that's how you would write an equation in standard form. So far we've talked about how to write an equation in slope-intercept form from various information, how to write an equation in standard form from various information. So now what we're going to do is we are going to look at writing equations from a graph. And when you look at writing equations from a graph, the 2 really easy ways to do this is to write your equations in either slope-intercept form or point-slope form. It is not always going to be easy to write your equations in standard form from a graph because, again, standard form is just a really unhelpful form for us. It will be helpful later, like when we get to Unit 5, but right now it's just really unhelpful. So what I'm going to do is I'm going to look at these 2 graphs and I'm going to write their equation in both slope-intercept form and point-slope form. So we'll just do a quick reminder. Slope-intercept is y equals mx plus b. And then point slope is y minus y1 equals m times x minus x1, okay? So in order for us to do this, for both equations, we need to know our slope. For slope-intercept form, I need the y-intercept, and then for point-slope form, I need the point. So what I've done for you is I have listed out the slope, y-intercept, and point. We gotta find those first. And then once we know those, all you have to do is plug them into your equation. You don't even really have to do any work, which is super awesome. Okay, so let's start with slope. The slope of this line, we really just need to figure out where our points are. And it looks like our points are all over here. So our slope is going to be rise over run. I'm going up 1 and to the right 1. Those are both positive directions, so my slope is 1. My y-intercept is where my graph crosses the y-axis, which happens to be at 0. You could also write this as a coordinate if you wanted to, 0, 0. And then you guys have a 1,000 options in this graph for a point. So just choose one that you like. I like this point. This point is 3, 3, but you can choose any point on your graph as long as it goes through that line, or as long as the line goes through that point. Okay, slope-intercept form, I need my slope, which we said was 1, and I need my y-intercept, which we said was 0. You could also write this equation as just y equals x. Both of those equations are acceptable. And then point slope form, okay, so we have to, this one's actually pretty easy because no matter what, your point is the same number twice. But you have to do y minus y1. Y minus y1. And remember that your y1 value is this one back here. So you have to switch directions, like you have to switch your coordinate, your x and your y have to swap places when you take it out of the coordinate, and you have to change signs. So I'll show you like better what that looks like in the next example, but just keep that in mind as we do this one. So y minus y1 equals x times x minus x1. I don't know why I put x1. I know what x1 is. Silly. And so there is my x value. Okay, so I've just written my equation in both slope-intercept and point-slope form. This one, you're going to have only one equation for slope-intercept form, but you can have multiple equations for point-slope form just because there are so many points in this particular graph. All right, let's do the same thing with graph number 2. Let me zoom in, please. That's too far. Back up. Back up. Okay. I'm going to go from this coordinate down here to the middle coordinate. I'm going up 1, but then I'm going over 1, 2, 3, 4 to the left, which is -4. So remember, up is a positive direction, left is a negative direction. So my slope is going to be a -1/4. It doesn't matter where your negative goes. I usually just put it with the numerator. Okay, your y-intercept is where your graph crosses the y-axis. That happens there at +2. You could also write this as 0, 2. And then you need a coordinate. I'm going to pick this coordinate for funsies. That is coordinate 1, 2, 3, 4, 1, 2, 3. So that is -4, +3. But again, you could have chosen another one. It matters not. Okay, so for slope-intercept form, I need y equals, and then my slope, which is -1/4 x, and then your y-intercept, which we said was 2. Okay, so for point slope form, remember that we got to do a switch and a switch. So this will be y minus 3 equals -1/4 x plus 4. Okay, so here was my coordinate, -4, 3. We got to switch their places, and we have to switch their signs. So because my 4 was negative, it becomes positive in my equation, and because my y was positive, it becomes negative in my equation. Okay. Now, we're going to talk about how to write an equation from 2 points. When we write an equation from 2 coordinates, it really is easiest to write the equation in point-slope form, but you don't have to. But I'm going to show you how to do it in point-slope form only because that's really, truly the easiest way to do it. Okay, when you write an equation of a line in point-slope form, you need 2 things. You need a point, and you need your slope. Shocking, right? The whole formula itself is called point-slope form. So here's the good news. If you need a point, we have 2. Okay, we've got a point here and a point here. Both of those are points, so you already have that. So the thing that you don't have, though, is your slope. So my suggestion is to always find your slope first. And you know how to find slope between 2 points. It's your y2 minus y1 over x2 minus x1. So it is going to be 6 minus 8 over 0 minus -1. That's -2 over 1, so your slope is -2. And then you've got a choice. It doesn't matter which coordinate you pick. I'm going to pick the first one for no reason other than I like it. Okay, so to plug this into point slope form, it is y minus y1, which is 8, equals your slope times x minus x1, which is here. And then we plug in our slope here. So we've already written our equation in point slope form and we're done. Does it mean that you could only write this equation in point slope form? No, I could have written this in slope intercept form. There's a little bit of different work I have to do. I could also write this in standard form, but again, there's work that I have to do. Standard form should never be your go-to. It should always be slope intercept in point slope form, and then standard form should be only if we ask you to write it in standard form. So let's do the same thing with number 2. It says write the equation of the line that passes through the points of 0, -8 and -2, -7 in point slope form. So I'm going to find my slope. That's what I'm going to do first. So that's going to be negative 7 minus negative 8 over negative 2 minus 0. This is really negative 7 plus 8 over negative 2, which is really 1 over negative 2. So my slope is a negative 1/2. And then again, you can use whichever coordinates you want. I'm going to use this one. Why? I don't know. I just am. Okay. I guess I'm just doing that one to show you that it doesn't have to be the first coordinate that's listed for you to use. You can use either coordinate you want. So this one will be y plus 7 equals negative 1/2 x plus 2. So my slope goes there. This goes, this goes here. And this guy goes wee all the way over there. And that's how you can write an equation from 2 points in point-slope form. Okay, so very similar to given 2 points, write an equation in point-slope form. I might ask you to write an equation of a table in point-slope form. I could also ask you to write your equation in slope-intercept form. So this part of our notes actually tells us to write the equation of the line in point-slope form, but I'm going to do point-slope form and slope-intercept, just so that you get practice with both. So, and slope-intercept. We're going to do both, okay? So for point-slope form, that is y minus y1 equals m times x minus x1. And then for slope-intercept form, that is y equals mx plus b, okay? For both of my equations, I need to know my slope. So we're going to find slope first, no matter what. Step 1, you need to find your slope. We talked about finding slope from a table back in 3.1 when we did slope. Okay, you have your 2 coordinates that you're going to use. Here's your y2 and your y1, your x1 and your x2, and you're still just going to use the slope formula. So negative 7 minus negative 10 over negative 1 minus negative 2. I chose really disgusting coordinates. Sorry. Okay, so this is going to become negative 7 plus 10 over negative 1 plus 2. That's going to be 3 over 1, which is 3. Okay, that's not bad. Now that I know my slope, I know that my slope is going to go here, and then we're going to also bring it over there. For point slope form, I just need one of my coordinates that are in my table. It doesn't matter which one you pick. I'm going to pick this one. Okay, that's going to go into point slope form. So point slope form is going to be y minus y1. Our y value is a negative 1 over here, so it becomes a positive 1 in my equation. That is going to equal 3 times x minus x1. And there is my equation in point slope form. Now, if I wanted to write my equation in slope-intercept form, I would need to make sure that my y-intercept was in my table. And your y-intercept is always where your x value is 0, which happens to be here in my table. That is not what I wanted. I wanted u. 0, negative 4 is my y-intercept. Okay, that one I don't have a choice on. So my equation will be y equals 3x minus 4, and that minus 4 comes from this value here. And we did it. So let's do it again. First thing I'm going to do is find my slope. Here's my x1, x2, y1, y2. First step is slope. So we've got 7 minus 8 over 4 minus 0. This one's way better. My slope is a negative 1/4. Okay. I'm going to look, my y-intercept is in my table, and then I'm going to pick this coordinate for my point slope form. There's not a reason for it, that's the one that I want. So we will do y minus 6 equals negative 1/4 x minus 8. So there's my equation in point slope form. And then next I'm going to do slope-intercept form, which will be y equals negative 1/4 x minus, no, plus 8. That comes from this value here. And I did it. Now, at the very bottom, there's this really, really important bolded statement. As a reminder, any problem can be written in any form. For example, we can write equations from all of these relations in standard form. We would just need to write the equation in the preferred form first and then convert. So what does that mean? I'm going to specifically show you with this problem here, okay? If I ask you to write the equation of your table in standard form, you can never do that first. There is no possible way for you to be able to do that. Instead, you're going to have to write your equation in one of these two forms. It doesn't matter which one you write it in, okay? I almost always prefer point slope because slope-intercept isn't always available to you, especially if your table doesn't give you your y-intercept. So what I'm going to do is I'm going to show you how to convert out of point slope into standard form. We've done this before, okay? But I'm going to convert this into standard form. Standard form is your ax plus by equals c, okay? So you have y minus 6 equals negative 1/4 x minus 8. I need to convert this into standard form. Your top number goes over here, and your lower number goes to the left. That's the rule. Your lower number goes to the left. So this will be, oh gosh, 4y minus 24 equals negative x plus 8. So I just distributed both directions, okay? Standard form, the x and the y have to be on the same side, so I'm going to add x to both sides. And then I'm going to get rid of this 24. It's got to be over here. So you have x plus 4y equals 32. So all three of these equations here actually represent the same graph, and I'll show you what I'm talking about here, okay? I'm going to go to Desmos. There's so much up here, I apologize. Ooh. Okay, so we're going to start with our point slope form, which is y minus 6. So we've got y minus 6 equals negative 1/4 x minus 8. Okay, so there's my line. In slope-intercept form, our equation was y equals negative 1/4, the slope should be the same, x plus 8. Hey, look at that. My black line and my red line are the same. Why are there so many dots on there? I don't know. Okay, red, black, red, black, red, black, red, black, red, black. They're the same line, different equations. Now, when we did all of this in standard form, we had gotten x plus 4y equals 32. And look at that, guys. My standard form equation, my slope-intercept form, and my point slope form, they all are representing the same line. They're just in different forms, okay? So just because I ask you to write it in a specific way doesn't mean that's the only way you're ever going to be able to write it. The thing that you have to remember is you must write your equation in either slope-intercept or point-slope form before you get to standard form. You cannot just write things in standard form. You cannot just write things in standard form. Okay, I'm going to say it again. You cannot just write things in standard form except here. From a word problem, you can, okay? But from everything else, we're going to write it in a different form first. Okay, that is all I have for you. I apologize for being long-winded, but you know that's how I am as a person. If you have any questions,